Welcome to The Explainer. Today, we're diving into a story that sits at a pretty wild intersection. We're talking spirituality, ancient philosophy, and some of the most advanced technology on the planet.
Okay, so let's just jump right in with the central question from our source material today, and it's a real mind-bender. Can you actually take a sacred prayer, translate it into code, and run it on a quantum computer? It sounds like science fiction, but the sources we're digging into, they don't just ask the question, they actually give it a shot.
To really wrap our heads around this, we first need to understand the stage where this is all happening. And that's the world of quantum computing. It's strange. It plays by a completely different set of rules than the normal computers we use every single day.
So, think about the phone in your pocket. It's built on bits, and a bit is like a light switch. It's either on, which is a 1, or it's off, a 0. That's it. Simple. But a quantum bit, or a qubit, now that's a whole different animal. It can be a 0, it can be a 1, or it can be some combination of both at the exact same time.
This both-at-once ability has a name: superposition. The best way to think about it is like a spinning coin. You know, right after you flipped it and before it lands, it's not heads and it's not tails. It's a mix of both possibilities. And that is precisely what gives quantum computers their incredible horsepower. They can explore millions of possibilities all at once.
And just when you think it can't get any weirder, it does. There's something called entanglement. This is this bizarre invisible link between two or more qubits. If you measure one of them, you instantly know the state of its partner, even if that partner is on the other side of the galaxy. Einstein himself called it spooky action at a distance, and honestly, he nailed it. It's a key piece of our puzzle today.
Okay, so we've got the ground rules for our quantum stage. Now let's see how our source material takes these rules and does something incredibly creative with them, building this bridge between a sacred prayer and a real quantum circuit.
So the source proposes this really fascinating metaphor. It maps the 4 parts of the Islamic Declaration of Faith, the zikr, La ilaha illallah, onto a quantum algorithm. It breaks down into 4 steps. La, which means there is no, a kind of negation, then ilah, or deity, representing all the possibilities, followed by ilah, meaning except, which sets a condition, and finally Allah, or God, representing this ultimate singular unity.
And this mapping isn't just conceptual, it gets really specific. Each piece of the prayer is assigned an actual quantum operation, what we call a gate. So, La, the negation, becomes a gate that literally flips a qubit state. Ilahe, all the possibilities, uses a gate that creates that superposition we talked about. Ilah, the condition, maps to gates that create that spooky entanglement. And Allah, unity, uses special gates that create a kind of hidden internal shift.
And this is where a single, truly remarkable number steps onto the stage: 64. It just keeps showing up, acting like this connecting thread between the quantum world, the digital world, and the ancient world.
Now check this out, because this is where the source draws a really powerful parallel. A quantum system with just 6 qubits can exist in exactly 64 possible states. Meanwhile, in modern computing, a common standard for encoding data is called base 64, and it uses, you guessed it, 64 symbols. And then you go way back to the ancient Chinese Book of Wisdom, the I Ching. It uses exactly 64 hexagrams to describe all the possible states of the universe. It's pretty amazing, right? 3 totally separate domains, all converging on the same number.
So the source material starts to see this whole experiment as a kind of cosmic dance. The 64 possible outcomes, you can call them quantum states or base 64 symbols or I Ching hexagrams, they're the dancers. And the strange, beautiful laws of quantum mechanics, that's the choreography, guiding all these dancers towards some final, meaningful pattern.
So that's the beautiful theory. But what happens when you take this metaphorical dance and actually try to perform it on a real quantum computer? Well, this is where the clean, perfect world of ideas slams right into the messy reality of today's tech.
In a perfect noise-free simulation, this quantum zikr circuit gives you a beautiful, clean result. You can see it on this chart. Out of 64 possible outcomes, just 1 or 2 get a really high probability. All the rest are basically 0. It's a crystal clear signal.
But here's the catch. Today's quantum computers live in what engineers call the NISQ era. It stands for Noisy Intermediate Scale Quantum, And the most important word there is noisy. These machines are incredibly sensitive and prone to making errors because of interference from the outside world.
So when you run that exact same circuit on actual IBM hardware, look what you get. It's much, much messier. Those high peaks from the simulation, they're a lot smaller now. And you get this floor of noise, where all these other states that should be zero are showing up with small probabilities. The clear signal is suddenly a lot harder to spot. But the source describes this in such a beautiful way. It's not seen as a failure. Instead, the output is like a stormy sea. The chaos and the errors are just the waves. But the true signal, the intended outcome, is still there. You can see it, like a small peak just managing to rise above that storm.
So what can we actually learn from this noisy, stormy output? It turns out the most interesting part isn't just about what the circuit was supposed to do. There's a deeper logic hiding in what it actually did.
This brings us back to the logic of the I Ching. It's not just a book of outcomes. It's a book about transformation. For example, a fundamental change is starting with the creative, a state of all ones, and watching all its lines flip to become the receptive, all zeros. Another key transformation is a minimal change, where just one line flips. The results from the quantum computer seem to follow a very similar kind of logic.
And here is the key finding, the big reveal. The quantum circuit's most likely answers weren't just the next hexagram in numerical order, no. Its top results were the ones that represented the most logical transformations, a complete inversion from one state to its opposite, or a minimal, single-line change. It's almost as if the quantum dance was following the deepest principle of the I Ching, the logic of change itself, not just the page numbers.
So, where does all this leave us? Let's try to distill this down to the big takeaway. What's the final message hiding inside this whole quantum prayer experiment?
The most important point from the source is this. This was never about trying to prove that a prayer can literally control a computer or that the I Ching can predict a quantum outcome. That's really not the point at all.
Instead, this divine coding is a really powerful metaphor. Think about it. The goal of the zikr, the prayer, is to find a sense of unity in a world that feels diverse and chaotic. And what does the quantum circuit do? Through this amazing process of quantum interference, it finds order, that clear signal, emerging from the chaos of all that quantum noise. The two processes are a mirror of each other. So why does exploring such a strange connection even matter? What's the real takeaway from all this, for you and for me?
Well, it shows us that real innovation doesn't always come from just pushing forward in one single field. Sometimes, the biggest and most exciting breakthroughs happen at the boundaries, at the edges where different ways of thinking collide, scientific, philosophical, even mystical. It really leaves you wondering, what other secrets are just waiting out there to be unlocked when we bring ancient wisdom and future technology together for a dance?